Hi everybody, sorry to come from the side. Today we're going to go through what is a 5-axis CNC milling machine with the Pocket NC I've got with me today, and my name's Tom. So I say hopefully we have a good session going forward, and please bear with me. I'm juggling between two computers, as you can see, the one in the background there for the CNC, and then the one that's capturing me now. So at any time, if you have any problems or questions, please feel free to type them in the chat, and we can grab them as and when needed, and we can go through those. And say what we'll do is an overview. So we're going to go from the very beginning to if you like the end of what you could do on the Pocket NC. But as I say, always, if you've got questions, please let me know. What I'll do for the time being is I will hide the web camera, and I've got a very brief presentation. It's a few slides just to set the scene, basically. And the first thing we're going to go about is three bits, really. What is a Pocket NC? The beginnings of where Pocket NC started, because it might be a company you've not heard of before. And how do we start machining? And that's where we're going to spend most of his time today, is doing the actual machining, because that's the exciting bit. So the Pocket NC comes in two versions. The only difference between the two versions is the spindle. So the one that I'm demonstrating today is the V210. That's ideal for plastics and soft aluminiums, and that's got, obviously you can see the travel, so around 100 mil cube, not quite. You've got an A and a B axis, which we'll go and show later on. Feed rate of 1500 millimeters per minute, and a maximum spindle speed of 10,000 RPM, and that works purely off of mains electricity. And all you need to do is plug a kettle lead in and a USB cable into your laptop or your computer to run the machine. But we do have another version, which is meant for a bit harder materials that you can do if needs be. And the main difference here is the collet changes from an ER11 collet to a CHB. So the tools go from a 6mm shank to a 4mm shank, or an eighth of an inch. Same travel, same feed rate, but the spindle speed goes up, and that's why we generally say that's better for harder materials, like for instance like steel. If you wanted to cut that, obviously you have a lower depth of cut than plastic or aluminium, because you've only got so much torque in the machine. But the spindle speed really helps with surface finish. So they're the two main ones, and then the final bit of it really is what you see my Pocket NC comes with, and that's the enclosure as well. Really good if you need an enclosure on a desk in an office, for instance, like I've got today, or say if you're in an education scenario, you've got door latches, so we always call them interlocks on proper machines, but same thing. So you open the lid of the door and it switches the machine off, so you're not going to do anything dangerous. You've got a removable swarf tray at the bottom as well, which is quite handy, and the lid lifts up as well, obviously with the handle, you can see. But let's not go too much into that. The other thing, brief things that are mainly to tell you about is, well, what is Pocket NC? When did it start? What's it all about? It started by two people back in 2011. So it's been around a fair while now. As obviously you can see by V2, this is the version 2. The version 1 came out in 2011, and the main difference now is the A and the B axis is a lot more sturdy and a lot stiffer. But it was really inspired by, you could get a desktop 3D printer, and why couldn't you do that for prototyping for milling machines? And that's where they saw the need, and say it's been a great machine. I've had this one particular for 2.5 years, nearly 3 years, so it's been really good. I had lots of use out of it, but hopefully we can show some of that today. So yeah, let's take a look. So what I will do is I'm going to carry on sharing my screen, and it's just briefly so we can see how we interface with the CNC machine. So what I'll do is I'll put on my webcam again, so hopefully you can see that at the top, and you can see what's on this screen currently here. So what I'm showing on the screen is basically what your control would be. So if you think of a traditional CNC machine, you'd have your big CNC machine that we could stand in front of rather than sitting down at. And on the side of it, you'd have a panel, and on that panel, you could add your G-code, you could move the machine, you could change anything about it. And we've got the same here. So if I moved the lid up, we can do the same thing. So for instance, I can add in commands if I need to. So I could say, for instance, I want to go G0 X, say 20, or it might be X minus 50. And if I went like that, you can see that the gantry of the machine will start moving forward to us, and that will come pretty close to the end. So we can do that manually, and we could say, well, actually, I want to do G0 and I might want to do A90. So you don't have to know G codes off by hand, but it does help. And you can see now the bed of the machine is moved in, and I can see that if I move that a bit closer, so you don't want to see necessarily my face, but you can see the machine would be set up into a position for, say, traditional 3D milling. This would be a horizontal machine in this instance. And you can use the machine like that because there are, going slightly off kilter a little bit, there are work positions, so G54 to 59. So you can set those by default. But we'll come back onto that in a bit. You can see you can move them there, and you can move the machine how you want to. And if I went to home all, it'd move the Z back, it'd push the X back into the corner, and then the A axis will flip back. So you can start from a known position every time. So that's really handy. And what we're going to do to start off with is I'm just going to start a machining program, and then we're going to come back and kind of full circle, and then I'll show you how to load the machine, add the tool, add a new tool in, and how to measure it and all that kind of good stuff. So yeah, we'll just wait for the A-axis to come round, and we can get started with that. I'll keep you on my screen, and then I'll turn it off when it starts machining, so we can see it there. So what we can see is we're all about to go. You can upload a new file, and it will take a .nc or a .text file, and I've generated mine in a CAM system, which happens to be solid CAM. But if you've got a CAM system with a post processor, great. Some companies offer them with the CAM package already. Obviously, we use SolidCAM and SolidWorks because our sister company is a SolidWorks reseller. But you can manually code it as well and just put a .text file in if that's what you'd rather do instead. That's what you can do. So you can see here I've got this file, and it's tool 1 cutoff because basically I've got my finished knight, and I'm going to take the bottom off it. So we're going to end up with, if you can see that, you might not be able to see the full detail, but that's what we're going to end up with in a moment. So you can see I can go and press run, and you can see the code. I could check the code if I wanted to underneath. So if I go and run, you can see it's going to start the machine off. Then I could think, yep, that's good to go. I could close the lid, and I'll move the laptop closer in a second so you can see it a bit better. But you should be, hopefully, if I tilt it down a little bit, you can see there is a green flashing light. Green flashing light probably means go, and it definitely does in this case. And that will start the cycle. And actually, I'll leave the lid up because I'll show you something really handy, which kind of I think gets overlooked slightly. So if you think, yep, that's going into position, that looks really great. No, that's wrong. There's a safety stop just there for you. So the red light, safety, the green light, obviously cycle start. And if I just went to home all on that one quickly, it'll just go and home the positions, and then we can go and if I start machining. The other thing to note on my screen, as you can see, the feed rate there is at 5%, so we can manually override what the feed rate is going to be. Now that doesn't apply to rapid moves, but does apply to feed rate moves, so G1s, G2s, and G3s. So if I go and click run from again, you can see it's the same process again. We can see, yes, that's looking great. I can go and press play. I can close my lid down. Again, I've got the safety switches turned off on this machine. I would recommend you keeping them on for when you first start. And you can see that feed rate is going really slow to start off with. If I bring us a bit closer to the machine, you can see there it's cutting really slow. And I can go quickly and I can ramp up that feed rate, and you can see it starts turning. Now, if I stop sharing my screen, and then we can go, and what we'll do now is if I go and ramp up that feed rate, we can see there now we're starting to cut, and that's going to go round, and it's going to take that corner off and that bottom section. So really handy. And what we're doing here is, as I mentioned before, we've got multiple axes. I showed you the A axis rotating to 90 degrees previously. Now here we're using the B axis. So we've got a 6mm end mill in there at the moment, and that's just going round and using the B axis to rotate all the while. So that's what we traditionally call a 4-axis operation, and you can see it's just humming away nicely at 1500 RPM and 10,000 RPM, and it's cutting quite nicely. And the material we're using here is Delrin. Reason for Delrin, it's easy to clear away, and it gives you a really good surface finish. But as I said before, we've cut aluminiums and steels and so on and so forth. And there's a really big community, even worldwide, that give you, have gone on and done some great things. I even saw a few weeks back someone had made the SpaceX launch that made the Dragon capsule for the top, and that was a really good thing to see. And as I say, they're all online, and say a really big community around it. So yeah, that's as simple as it is really. When you come into cut, so you obviously upload a file, you press go, you press the cycle start. If you go wrong and you think it's going to do something bad, press red, and that'll stop it for you. And as I say, I'll just go through and it'll cut it. And if I go and briefly show my screen again, you can see in here that it's just cycling through the code, so we can see that as it goes through. Now, one thing I didn't mention is that I've already obviously run this before, and I know it's going to cut nicely. But if you hadn't run for the first time, how do I know my machine is going to work well? Well, there is an answer for that, and it's a really nice one. That Pocket NC do supply a simulator, and that is just sim.pocketnc.com. So if you add some G code like I've loaded in here, and this happens to be the main of the night here, and I'll show you on a video in a little while, so you can see that operation being cooked. And what you can do is you say upload it. You can choose whether you've got the V210 or the V250, and all you have to do is press play. And you can see in here, it's going to go and load up my toolpath. It's going to recognize what the toolpath is doing, and then from there, it will go and do the machine kinematics. Now, it won't give you, obviously, the solid lump that you cut in. All it is doing is checking the machine's not going to collide with itself. But nevertheless, it's checking the G code that you're putting in, so it can be really handy, especially on something more complicated. Like when I go and press play on here, hopefully you're going to see this looks a bit more complicated than your average toolpath. So you can see the A and the B axis all moving together, and they're going to go around. I say the limitation with it is that you don't see the part that you've made, and it will just put in a default tool for you of 1/8 of an inch. But I say it's the representation that we want to see, that we've seen all those clearances. As you can see, it's going to clear on the back end of the main, and it's working its way around slowly. And you can go, and that's obviously how quick it would machine with the feeds and speeds I've put in. But you can see if you want to be a bit more adventurous and just check it, it'll go through and do it for you. You're going to ask though, what happens if I do something wrong? Really easy. It stops and it shows the 2 bits that have collided in red, so you know exactly what's gone wrong. And obviously you can go and change that in your code that you've produced. So as I say, works really nicely and just gets on with the job for what we need to do. So as I say, that's as simple as it needs to be, really. It could be, this could be anything. And like for instance, if I refresh the page, Pocket NC provide just a standard square, so you can just see a square being cut. And I say it'll do anything from easy to difficult. It won't worry about how many lines of code you've got in, because you can see at the moment with mine I've got something like 5,000 lines of code in this particular operation, just because it's not the way the code's being made. It's not being made with arcs, it's being made with lines. But I've had hundreds of thousands of lines and millions of lines of code before, and it's not better than annihilate. I say it's just going about its way, cutting down the bottom there. And say if I bring this in a bit closer again, you'll be able to see that just cutting away, and it's I say gonna go through and keep doing that as we go along. But I say nothing too crazy on that. The other thing we can do is if I go and I'll show you a quick video as well of different parts of it being machined to get to this point. But remember as well in the chat, if you've got any questions at all, just feel free to type those in. And obviously I'm here to help. And if you want to know anything more about the technical specs, or what have you cut, or what would you recommend for tooling, all that kind of good stuff, I'm more than happy to help on that one. So if I go back then onto my main screen, and as you can see, as if by magic, I videoed this a couple of days ago, and you can see this is on a pre-roughed state. So you can see I've roughed out the initial shape, and then I've got a 1mm cutter in here. And the reason why I've got a 1mm cutter in here, just cutting around the side of it, mainly is because I can. I've got a 1mm cutter, I want a really nice surface finish, and I have nobody pressurizing me for this must be done in an hour. So if you want to do it nice and slow and get a mirror-like finish, yep, we can do that. And obviously if we're a bit more time sensitive, we'd probably use a bit bigger of a cutter. But you can see that looks quite nice. And this comes into more of the, if you like, this is positional 5-axis rather than just the 4-axis there. So I've locked the B axis at about 15 degrees, and I'm just cutting around the corner. And then again here's the main being cut, so that simulation you got shown before. Obviously you can see the surface finish a bit better there on the video than you can do live, but I'm always conscious that you want to see both the surface finish, you want to see it live in action. So hopefully this is the best of both, and you can see both in a good view. You can see just cutting away as you'd expect, the same speed as what we showed earlier on the simulation. You can see there my not so keen handiwork with the camera being a bit wonky, but you can see there I've just got the B axis spinning round, so you can see the surface finish as it is and as it's finished there. So it's like really powerful there, and that spinning round was just me putting the B axis to G0 B 9000 or something like that, because I'll just keep the B axis spinning. And that kind of comes onto a nice point, really. If I come out of that for a second and come here, you can see on the DRO here where we're currently at with what we've machined, and you can see that the B axis is it's winding itself backward and forward. You don't have to do that. The Pocket NC will know where sorry, I've just seen from John, you can't see my screen, which I do apologise for that. I was talking away there and you didn't actually get to see anything, so apologies for that. So I'll run through it briefly again for you. You can see there it's going through and cutting the first section, and then if I speed it along a little bit, then you can see the positional 5-axis, and then from there you can see how we cut the main. So always handy to have a spare set of eyes for us on these webcasts. But yes, sorry about that. So yeah, you can see that's the simulation we did earlier. So yeah, hopefully now at least you can see both the video and the machine cutting as well. And as we've done that, it's actually about finished, which is quite handy. I know a question I get asked quite often: how loud does the machine get? I don't know if my microphone's picking it up too much on my headset, but this is about as loud as it gets, and to the machine, I'm about a meter and a half away, but I say it's not too loud. You can definitely talk over it. It's not something that you have to put in the back corner and worry about it being a drone all day. So yeah, what I was mentioning before, as well, as you can see, actually, if I come back here, you can see that's just finishing off for us now. So we can see there we've got the machine finishing and just unwinding for us. But that's a manual rewind I've put into the program, not one that's actually needed. So yeah, that's got us pretty much as we need. And obviously the way I've made it is there's a little 1mm sprue at the bottom. So all I need to do is twist it off. Then obviously I can take some of the swarf off, and you can see at the bottom, just cut the bottom tab, left a little bit of swarf on the bottom. But you can see there again, that's another one of my knights that you can see there. I can just see there's been a question about threaded parts. Now, that's a good question. You can thread mill. It will not use a thread milling cycle. It'll have to be longhand coded, but it can be done. The limitation is that for the V250, it needs to be able to fit in a form. The shank of the thread mill needs to be 4mm, and for the 210 that we have here, it has to be 6mm. Now, it's not the end of the world if you can't find a 6mm shank. And why I say that is because we can get them reground. So if you bear with me a second, there is one tool I've got which is just out of reach, as typical would be. And this is an 8mm taper ball nose that I needed for I was actually doing a turbine wheel. And if you can see, that picks up quite nicely. That there is a reground one. So we can do that as well, you know, if that needs be. So that's a service that we do with our tooling partner, Mugi Franken. And I say, if you've got any specific thread mills that you need, let us know, and we can sort that out. It's something we have done in the past, definitely. So yeah, let's go and talk about tooling, taking parts off and on and all that kind of good stuff. So the way we take a tool out, and not necessarily needed for this particular part I'm going to do, but to show you nevertheless, with the V250 it's slightly different. What it is a handle, and it's a quick release. So you don't have to use a 4mm Allen key like I am with 3 grub screws. That is just literally a handle you pull down, pull up, and that will go through. The V250 as well, I don't remember if I mentioned it before, is you need an air compressor because it sits on air bearings, the actual motor as well, to get the spindle speed. So that's just one to be wary of. But you can see there's the 210. This one's on the extended collet. So you can see that's R11 collet on the inside, 6mm shank on there. We can get shortened one as well if you need an extra tool length. And that particular one there, I used for the taper ball nose. And it, obviously just a lock nut. And I don't have a collet in here just for show. You can see it's just like so. So normally what we do is screw that in, and you do get a provided spanner to do this, so you don't have to worry about that. And then you can see I can clamp that in there, and then the V210 needs these 3 grub screws. Just make sure they're nice and tight. What you sometimes find when it's hot, obviously, it never gets hotter than this. You can easily touch it. It never gets more than, and just feeling warm in your hand. It doesn't, there's no heat build up in it. Yeah, obviously if it's warmer, it'll expand and get a little bit hotter and harder to use. And I would normally not use my hands. I have got a vacuum cleaner, but because I don't want you to hear a vacuum cleaner down my microphone, I am using my hands, and I'll have to wash those later on. So to show you how to take the part out, I'm just going to move you slightly. And sorry about that if that's moving around a bit too much, but if I come in there and if I do something like so hopefully you can see. And in here we've got obviously another collet. This one's an ER40 collet, and obviously I need to loosen it. So if we go left, I can undo it. Take my part out, and this is just 2 locking nuts and an ER40 collet in there, which today has a 30mm internal diameter. You can get them, I believe, up to 32, and there is a vise you can get as well. So if you want to bolt down, you can see there's all these bolt holes in the table. You can bolt down to them. Or there is a vise that comes with the Pocket NC, which if I do that, hopefully you can see. So it's only made for small work holdings really, but you know, can be really handy. And I've had people using even 3D printed parts, so that's pretty cool. Obviously not PLA, but not your ABSs, something a bit more heat resistant, just because PLA bends really easy. And you can see I'm just not finger tight. And the key thing with the Pocket NC that makes it really easy, especially with the collet, is that normally we have to figure out kind of where the position of everything is. But I can just home everything on the machine, and then from there I can tighten this down, and I can say roughly it's stuck out about 73, 74 millimeters, which is just about there. And I promise you, we don't have to, because it's stock, we don't have to be much more accurate than that. Does this affect the accuracy of the parts I'm going to create? No, and I'll show you why in a second. Because I said I used CAM before. In the CAM, I've programmed everything to be around the 2 rotating axes, so I know exactly where the axis is. And I can also measure exactly how long that tool is. Really handy. And you can do that for any tool. And in particular for this one, I'm going to go in and let me just move my go-to webinar because it's in the way. If I go and share this screen here, then you can see what I'm seeing. So in the tooling tab, and this is just on a Chrome browser, there's nothing extra than that. Don't need any extra hardware. It just plugs in by a USB, and you're off to the races. And on my Chrome browser, obviously I've gone to the tooling tab, and I can go and first of all home everything. So I can set home, and this is the G54 home. The reason why I know it's G54 home is because it says G54 at the top there, but I could change that by left clicking or right clicking to be whatever I need it. I say I got from 54 to 59. And then what I can do there is click measure tool. And I can see I've set this already up 6mm. So if I go measure there, it should be a familiar thing. You can't quite see it on your side, but I don't want you to, because I'm going to move you around slightly, and you can see the mess I've created this afternoon. But I'm going to press that green button that we saw earlier. The reason why I have moved you around here is that the carriage moves across, the bed moves up, and there's actually a probe at the bottom, which is really handy. So you can see it moves across, the bed moves up, and then I can see, and there should be a little blue button that we're going to go in, and you can't quite see. Unfortunately, I can't get the camera to get to there, but there's a little blue stainless steel button that it goes and probes the height, and then what that does is you can see it gives me today it is minus 75.49951 as my tool stick out. So then obviously, because I've made my CAM program with Z pointing that way, X that way, Y pointing up. And obviously I know the tool length, it knows exactly where the center is, and it's going to go and cut. And it's simple as that. There's nothing too more complex than that. So yeah, let's go in and do it again. So like last time, I'll close the lid. I'll move my laptop. As you can see, I'm getting a bit better at this, hopefully. I'm going to stay on the screen. And as you saw before, I can drop the feed rate down to 5% if that's what I want to do. I can go and pick, I want to use tool number 1 because I'm starting the job. I could go and have a sanity check and just double check I've tightened the parts, because that's always good to do. You can see, yeah, that's definitely tight. And I know the grub screws are tight. So yeah, let's go and run it. So again, if I go and click run from, it'll go run from there. And if I go and hit the green button, it's going to go through. You can see it's going to come close. It's going to feed in slowly, and then in a second you'll start hearing it making some noise. So I'm happy with where it's going, so I can ramp up the feed rate just by pressing the up arrow. And what I'll do is I'll turn off the screen share because you don't want to see me doing the up in the feed rate slowly. You could go straight from 100%, but it's mainly just to show you how safe it can be for you. If you've run, for me normally I just run this 100% straight away because I've run the toolpath multiple times. But you know, if you want to be extra careful, yeah, go for it, and you'll be fine. So you can see there, just get myself up to 1500 RPM, and you can see in here this is a 3D roughing strategy. Now, if I go and bring you a little closer again there, and I've brought the white material for this section because I thought that hopefully shows a bit better, because I did see earlier on the camera that it was a little dark. But I say all I've been using is 30mm Delrin, and just cutting that all the while. But while that's going through, if you've got any questions, again, please let me know in the chat. Obviously, can happy to answer them if you have any. So yeah, you can see that's going through and making plenty of chips now, and that's what we want to see, isn't it? So as you can see on there, so that 6mm cutter just hopefully making fairly light work of it. I think today for this roughing pass, we do for an idea, we're doing about a 1mm step down and a 100% step over. So you can be reasonably aggressive for how small the machine is. So I can, sorry, I've just been given a question or two. I'll just grab them out here. So a good question here I've had is, how long does it take to learn full 5-axis? I can see actually there's a few questions. Sorry about that, chaps. I should have come to them sooner. So Guy, how long does it to learn 5-axis programming? That's a very good question. If you've had experience with 3D or 2.5-axis, traditionally on our training courses that we do, we believe we can get you up to speed in about 5 days of classroom training. But obviously that's with an appreciation of some milling before. I think that the main thing that most people struggle with is the initial setup of the machine. Once you get machine in the correct place, like we talked about earlier, then the toolpaths you see on your screen, if you're using CAM, become a lot easier. And especially with the Pocket NC simulator, because that'll show very quickly if you've done something wrong. So it obviously, like anything, can take a little while to master, but to get using 5-axis toolpaths, I'd say you could do that pretty quickly. Right, so I can see, can it machine threads? Yes, it can. We've been through that one before. Is the NC code fed to the machine via USB connection? Yes, Guy, you would require the USB cable to be plugged in, but if you've got the laptop on, but you can use Linux CNC over Ethernet as well, if that's what you prefer to do. So that the machine then could sit on the network and then you could push jobs to it. So there is ways around it if you don't want, if you like a laptop next to it, you could plug into the network and do it that way. Right then, that's all looking pretty good for now. But just say if you've got any other questions, please let me know. I can keep grabbing those for you as and when we need. But yeah, going back to what's the learning process of it. Obviously, there's two bits really. There's the machine and getting comfortable with the machine, and obviously that slow feed rate to start off with, and setting up in the collet makes it nice and quick to learn that. And I think the other bit is obviously the getting to know if you like the cam. If you want to do more complex parts, to do simple parts, you could just do hand coding if you wanted to. I can see as well Max has asked about knurled parts that I'd missed. Knurled parts, I'm going to be honest, I don't know of anybody making knurled components on the Pocket NC. Normally knurling's done on a lathe, but if you can get obviously something that fits in the collet that can do it, yes, it could do, because it's not a massively intensive operation. But yes, I'm going to be honest, I haven't seen anybody do it on the Pocket NC. And I've got another question as well. Does SolidCam and other CAM programs have a dedicated post-processor for the Pocket NC? Does the code need any manual editing before use? Now, for myself, I use SolidCam and SolidWorks CAM. And that's because of the sister company to SolidPrint 3D is a SolidWorks reseller. I can say very confidently there's no manual editing needed for SolidCam or SolidWorks CAM's post processors, at least the ones that we have. The other CAM systems, I'm going to be honest, Guy, I haven't tried them, so I couldn't comment. I know that people do machine on them. What manual editing they do or don't do, I don't know. If truth be told, it's something we could look into. If you need it, if you're in another CAM system, we could talk to the that provider. So yeah, I know another question as well I get from time to time is how do is there a specific program that I need to open the code in? And that's the answer to that is no. So as long as it's a .text file or a .nc, it's fine. So if you're just on Notepad, that works. Or you could use Notepad++ or Visual Studio Code. They all work perfectly fine. Other things that I haven't mentioned as well that you do have, I'll just flick my screen on briefly, is that you can use your keyboard and mouse to control the machine. Obviously, I can't do that quite at the moment, but you can use obviously Z for Z, X for X, Y for Y, and then the plus and minus keys on your arrow, plus and minus keys on the keyboard, and that will move them backward and forwards. Or you could use a scroll wheel on your mouse cursor as well, and they work really well for setting up a job. Because you might not always want to set, machine from center of rotation. Quite often, quite a few times in the past, I showed previously, I rotated the machine to 90 degrees, and I just machined end on using that G55 position. So yeah, that could be something as well. But hopefully that's looking pretty good. Hopefully you can still see the machine. I'll give it a gentle tap to get some of the swarf off it, but obviously it's just on that first half there of the roughing, and it's going to go and do the other half as well. So yeah, looking pretty good. But as always, as I said before, if you've got any questions, please keep them coming in. They're more than really good to see, and obviously yeah, please fire away with that one. But I think another thing that I hadn't mentioned previously as well is if I put that in front of the camera, this is the part we'll end up with. So it's going to go and rough that first side, and you can see it's just rotated round to that second blank side, and it's going to go and cut that second side as well. And that's what's called positional 3D milling. The reason why it's 3D is very much like if you like a 3D printer. If I put it on the side like that, it's doing, if you like, cutting a layer at a time, rather than when a 3D printer builds the layers up. We are cutting those layers away one at a time, and obviously giving that effect. But obviously we can go on then to finish it, which you wouldn't necessarily get with, for instance, an FDM printer. So yeah. So yeah, you can, as I said before, you can see on this one, it's just an exact copy of what we'd done previously, and on this, I believe it's around 10,000, yeah, about 10,000 lines of code to cut this in its entirety for what we wanted to do. I know another question as well that I get asked quite a lot is, is there a need for coolant? Safely say that I've never run coolant on this particular machine and not had any problems. I've cut aluminium, I've cut steel. It tends to be feeding depth of cut really, and that's your limiting factor. If you are cutting something more substantial, like your aluminiums and your steels, the V250 would be a better option, because you do get there is cooling because it's got a compressor onto it, so there is an air feed. But I say for the V210, I haven't been hamstrung by not having cooling so far. I can see as well from Steve, how long did the finished part take? So I'm going to give you two answers for this, Steve. The first answer is how long it took, and that is it took about 3.5 hours, and that is purely down to me taking my time with a 1 mil and a 0.5 mil ball nose cutter. So we are talking, I don't know if the camera will quite pick the tip of it up. So I say really small cutters, and the reason why I've done that is so I can show off and get the best possible surface finish I can. And I've done that rotating around the fourth axis. Now, if you use the same cutters, but not rotate around the fourth axis, but use full 5 axis, you could cut that down substantially, more to the tune of, I would say, 2 hours. But as I say, this part isn't really to show, it doesn't really show the productivity of the machine. It's more to show the capability of the finish. So it depends on what you're cutting, but say if you're making a prismatic part, it would be a lot quicker than something that looks fairly simple from day to day, but actually when you look at it, it's got a lot of compound surfaces and a lot of really intricate detail. Obviously we have to run slower because we're using really small tooling, and because of that you get a longer lead time. So it's a long answer to a very simple question, really. So, but yeah, if you have a part that you're interested in machining on it, you could always get in contact with us after the seminar, and we can have a look at that, and we could give you an estimate. So yeah, you can see that it's roughly about 3/4 of the way through on that roughing cycle now, and so it got through pretty good. So what speed would you use for copper? Again, a good question. The main thing with copper is obviously it's a ductile material, so it is quite soft, and it can have some obviously heat build up and movement due to that. So I would say most likely it does depend slightly on tooling, but I'd say you probably want it around the 8,000 RPM mark. And I would be doing, I wouldn't be doing full depth of cut, I don't think. I would be doing more something like 50% of the cutter, and maybe something like a millimetre step down, just so you're not overheating the material more than anything. That would be a limitation. You could cut it really easily, but obviously the main thing I want you guys to get is to get a dimensionally accurate part. And with working on copper on any machine, obviously you've got to be wary of the movement that copper could have due to the heat buildup in the actual material. Obviously, if you're using copper, potentially the V250 might be better for you, because obviously you get that blown air onto the part. But there's nothing to say, if you have a compressor, you can very easily retrofit an air feed onto the machine. I have had people do that with the V210 for specific applications. So yeah, that could potentially be an option as well, where you could run that. And got another question for about precious metals. I'm going to be honest, David. I don't have experience of cutting precious metals. I'm afraid I come from a heavy industry background, unfortunately, which is obviously lots of steels and lots of aluminiums, and I can't think off the top of my head anyone I know that is currently cutting precious metals. I think that would be something that we'd have to have a look at with you offline, on what you wanted to cut. I don't think the hardness would be a problem. Again, it might be a case of what the ductility of the material is. You can see about here it's gone to nearly finish off this part as well. So what you've got with the part is that we are going to come through, and what you'll have is, because I've done either side, is we'll have what's called an onion skin. And the way we can get around that is, obviously I said before, my part is 30 millimeters diameter. So you'll hear, if you like, a little crackling as the onion skin gets taken away in a moment or two. But that is done by making the toolpath around 15.5 mil deep. So you're definitely cutting past where the material could possibly be. It doesn't affect the finish of the part, or or what the roughed material looks like. It's just a way to make sure that we've got a rough stock that we can use for finishing more than anything else on that one. So yeah, that's pretty good on that one. A nice trick to know, and it's really handy for having the B-axis to rotate around. Another thing you can do as well, I haven't done it in this particular webinar, but you can also rough upside down. And the benefit for that is obviously all the swarf drops to the bottom. And as I said, the case that the machine's in has a removable swarf tray, so you can just hoover that up, or just dispose of that, dependent on what material you're using. So you can see it's just coming through. So I've just had a question about the quoted dimensional accuracy. When I received my machine, that's probably the best one to give you. I got given it would be down to around about 2.5 thousandths of an inch. So it is in inches because it's from the Pocket NC's from America. And with every machine, you do get a certificate, say it's been tested to a tolerance. So it's around and about 2.5 thousandths of an inch that you'll get dimensional tolerances to. As I say, I have had quite a few times where I've been, I make a 50 mil block and it's 49.999, just to make you think, oh damn, that's just not quite perfect for what you want. But obviously not going to cause any difference whatsoever. But yeah, they're around about 2.5 thousandths of an inch. And you can say, I was talking about earlier, that onion skinning, you can hear it just breaking off now for us. So it's just going to go through there. So I've had another question as well about vices for the machines. And Mark's got a small vice for the V250 but asking, are there any larger vices? Now, unfortunately, I don't know of any suppliers that do vices specific for the Pocket NC that are larger than the vice that comes with the machine. However, you can get 4-jaw chucks or 3-jaw chucks, depending on what you want, and they can fit into the ER40 bottom collet. And I know, a few users use those, and that can give you a bit more room, but it's not going to be huge amounts more, I'm afraid, on that one. And you can see it's just finishing off now. So if I go and open this slowly, so we don't get everything covered in white dust, but yes, you can see there. If I just come and move that a bit closer, you can see the part there is just finished. And I say from there, you can see I've got my tools that have splayed around a bit as we've been doing this today. But yeah, that's as simple as it needs to be. Obviously, we saw first of all the finishing off, the cutting of the bottom. Obviously, I gave you a video of the 5-axis, mainly because I could run it, but you can't. Yeah, it's easy to see the detail. And that was the key thing on that one. I wanted you to see the detail of the main and say that done all in a 1/2 mil ball nose, and we simulated that as well in the Pocket NC software. And I say that's available for everybody. So if you went to sim.pocketnc.com, you could try a bit of G-code and play with that today. And then obviously then we changed the tool, even though we used the same tool, but I showed you the process of changing the tool and yeah, and roughed the part out. But yes, I can see that. Right, I've got Steve coming in with a question, so I'll grab that one while we're talking. And it's, if you have an oblong stock, can fix with threads cut into the bottom of the stock, and how would you align it again? So I can understand what you wanted to say is if I'm cutting the top, if I'm making if like a box, and I've got an op one, and I've cut some threads into or some holes into the top of op one, and I flip it around, how would I get op two? Now, we could do that with the vise, which I've got over here, because the vise has got different mounting holes, and hopefully if those mounting holes fix, that works really well. I've also seen a couple of users that, remember before, with the vise, you've got 2 mounting holes here. So you've got a mounting hole there, a mounting hole here. With that, you can also mount with those, and a couple of our users have made themselves either a wood waste board and used something like carpet tape, a strong adhesive tape, and tape it back to front. Obviously not great for metals, but plastics works really well because you don't get that much torque on it. Or say made themselves fixture plates just on the bottom. So there'd be 2 ways of that. As it would be potentially custom fixture plate, use the vise that's provided, or it could be, I say, double-sided. For aligning, I tend to align off 2 faces. So what I mean about that is if I know where I am in position left to right and back to front, I could set a G55 operation 3-second one. So you could work off the G54 for the first operation, flip it round and then reorientate it, and then potentially just have something that makes sure it's it's clocked left and right, across A and across B. So just using G55 instead. That could work as well. I can see that we don't have any other questions at the moment, so I'll give you say a minute to fire away some other questions if you've got them for me. But apart from that, I think we've kind of gone through everything really that you can do on a Pocket NC for an operation. Or making a part. So yeah, hopefully it's been interesting and good to see it, and hopefully I say it's been almost as good as seeing it in the flesh, obviously in different times, but hopefully you know, seeing it through a webcam gives you the same flavour and the same excitement for machining, because at the end of it, the great thing about it is you can you can see what something being made from a CAD model. And I can see that we've had two questions. One about emailing video links afterwards. I believe that will be sent out for you after the webinar. The webinar has been recorded, so everything I've done should go out onto that for you. And the second one is, does the V250 come with an air compressor? Unfortunately, it doesn't, but it only requires 1 horsepower. I think it's actually 0.2 bar it requires to keep the spindle enough air. So it's a really low power one. Like for instance, we have a air compressor for V250 for testing, and I believe that was around 100 to 150 pounds. So you can get something, you know, very, very light use, and that will do you just fine. Obviously, if you want something a bit bigger, they would probably be 200 to 300. But unfortunately, no, it doesn't come with, the V250 doesn't come with a compressor, but it has a very low requirement. And I say they recommend at least 1 horsepower, but from memory, it's 0.2 bar that needs to go to the spindle. So, you know, really low amounts of air that's needed. So yeah, I think at that, I think we can leave it there for today. I can't see any more questions feeding in thick and fast. So hopefully that's been really good for you and exciting, and giving you a good glimpse into what a Pocket NC can do. And say if you need anything more, obviously please feel free to get in touch with us. No doubt. Say you'll see the webinar recording afterwards if you want to watch that again. And I'll see you all soon. Hopefully you all stay well. Thanks very much. Bye-bye.